Assalamu alaikum, dear students. I am Professor Naveed, Department of Physics, GC Okada. Today I will deliver you a lecture about work energy principle. Dear students, this is our fourth lecture. So let's start our today's lecture. Work energy principle. Its definition is the work done on the body is equal to change in its kinetic energy. Dear students, its definition is the work done on the body is equal to the change in its kinetic energy. In its kinetic energy. So mathematically, W is equal to delta K dot E. Work done on the body is equal to change in its kinetic energy. Dear students, suppose you have a body on a horizontal surface at position A. Its initial velocity is Vi. After certain interval of time, its velocity changes into Vf and body comes to its final position B. So initial velocity is Vi, final velocity is Vf. We have to find the work done. The distance covered by a body from A to B is represented by a letter D. So a force acts on a body. When a force acts on a body changes its position from A to B. Now using third equation of motion, using third equation of motion, that is 2as is equal to Vf square minus Vi square. Dear students, this is the third equation of motion. 2as is equal to Vf square minus Vi square. But here the distance covered by a body S is equal to D. S is equal to D. Putting in equation number 1, 2AD is equal to Vf square minus Vi square. And we have to find the distance now. So 2A is divided by Vf square minus Vi square divided by 2A. Dear students, 2A is multiplying on the left hand side. On the right hand side, it is divided by Vf square minus Vi square. Vf square minus Vi square divided by 2A. Equation number 2. So dear students, why will we find the value of D? Because you have to find the work done. You have to find work done, and work done is equal to the product of force and distance. So distance is measured or calculated by equation number 2. So moving on to the next page. Using Newton's second law. Using Newton's second law of motion. Newton's second law of motion, that is F is equal to ma. Equation number 3. So all you know that work done is equal to the product of force and displacement. Force and displacement. Force is represented by F, displacement is represented by D. So work done is equal to F, putting value of F, which is equal to ma, and D. Moving back to the previous page, D is equal to Vf square minus Vi square over 2a. Putting in above equation, Vf square minus Vi square divided by 2a, that is equal to W is equal to a cancels with a, acceleration cancels with acceleration, and the remaining portion is m Vf square minus Vi square divided by 2, taking constant before m, so 1 by 2 m Vf square minus Vi square, multiplying by Vf square firstly half m Vf square, and then secondly minus 1 by 2 m Vi square. So dear students, as you can see that half mv square is the formula of kinetic energy. So this is kinetic energy final minus, this is again formula of kinetic energy initial. Final kinetic energy minus initial kinetic energy, which is equal to change in kinetic energy. So work done is equal to the change in kinetic energy. This is known as work energy principle. This is known as work energy principle. Work energy principle. W is equal to delta Ke. Work done is equal to change in kinetic energy. Dear students, this lecture is available on YouTube. You can watch this on YouTube channel. So next article is a very lengthy article which will be covered tomorrow. So that's all for today. Uh, Allah Hafiz.